Hi everyone. Today let's see how we can solve the Leet code problem 542, which is 0 1 matrix. We are given matrix with zeros and ones, and for every one we need to find the distance to the nearest zero. Okay, and we can only travel either left or right or top or bottom, but not diagonally. So while I was thinking, I thought we could do this using breadth first search, and the procedure that I thought was like take all the zeros, and for every zero we go to the neighbor and update the neighbor's distance if it's nearby. Okay, so let's see that in action. So I'm initializing another array and I'm keeping all the positions of zeros as zeros, and for every one, as we do not know the distance to the nearby zero, I'm updating their distance as infinity or some maximum value. Okay, and I keep track of all the positions of zeros in a BFS queue. So position of first 0 is 0, 0, and the position of second is 1, 2. First, we consider this for every neighbor. So this is one neighbor, and distance of neighbor from here is 1, and it's less than infinity, so I update its distance to 1, and again to this neighbor distance is 1, it's less than infinity. Okay, and for every neighbor that I've updated, I'll add those to the queue. So 0 1 is one neighbor and 1 0 is other neighbor. Now I do the same for 1 2. These are the three neighbors. Okay, distance is 1, which is less, so I update and I add them to the queue. 0 2 1 1 and 1 1 is 2. Now for 0 1, which is this, so distance to neighbor is 2, but it's greater, so I do not update it. So this is the array. Now let's see the code. Here I will, instead of initializing another array, I'm using the same array and updated its distance. Instead of infinity, I updated to some maximum value, and all the zeros I've added to the queue so that I can do breadth first search for every one of them. Okay, while queue is not empty for every neighbor, and checking if it's a valid neighbor, and if the distance to the neighbor, new distance to the neighbor from the current node, if it's small, then I'm updating the neighbor's distance and adding the neighbor to the queue. If not, we do not do anything. If the distance to neighbor is already smaller than the current distance or equal, we do not add that to the queue. Once you're done, we return the matrix. See you guys later.